All right, continuation of the last section in chapter 1. I'm going to do a couple of exercises having to do with inequalities and also absolute value before we move to chapter 2. The first one I want to do is if you have x minus 2 divided by x minus 1, for example, less than or equal to 2. So on the left-hand side, you have this kind of fraction, less than or equal to some constant. This is the way you solve for x. First, you bring 2 to the left-hand side. So everything would be to the left-hand side, and you end up with only 0 on the right-hand side. So x minus 2 divided by x minus 1 minus 2 less than or equal to 0. Now, between these two terms, you give it the denominator of 1 to 2, and then common denominator between 1 and x minus 1 is x minus 1. X minus 1 into x minus 1 is 1. 1 times this numerator would be x minus 2. Minus, this is this minus, parenthesis, x minus 1 divided by 1 is x minus 1, multiplied by 2, it is, well, let me put 2 times x minus 1. Now the whole thing less than or equal to 0. Simplify this, x minus 2 minus 2x plus 2 divided by x minus 1 less than or equal to 0. This minus 2 and plus 2 would cancel, and x minus 2x would be minus x divided by x minus 1 less than or equal to 0. Now, rational expression here, minus x divided by x minus 1. As before, I'm gonna do this up here. We're gonna do a number line and find the critical points. So here's infinity, here's minus infinity, here is 0, say. So what we do is we set minus h, the numerator, equal to 0. So that means h should be equal to 0. That's one answer, or one critical point, one root, whatever you want to call it. And then h minus 1 equals 0. That means h is equal to 1. That's the second critical point. Now we would show these 2 points, h sub 0 and h sub 1, on this number line. So h sub 0 would be right here. H sub 1, let's say this here. Now you write the denominator, x minus 1. For what value x minus 1 would be 0? The answer is h sub 1. So you put 0 right here. You put 0. Any value less than 1 would make this, any value less than 1 would make this a negative number, such as 0. If x is 0, 0 minus 1 is minus 1. So it would make negative. Anything to the left would be negative. Any value greater than 1 for x would make this term positive, such as h of 10, let's say. 10 minus 1 is 9. 9 is a positive number, so you put plus to the right of this 0. Then you look at the numerator, minus x, minus x. For what value minus h is 0? Well, we did this. Minus h equals 0, that means h is equal to 0. So you come up, you put a 0 here. Then you would ask yourself again, If a value is less than 0, if a value of x is less than 0, what would you have here? Such as minus 10, for example. Well, it would be minus 10, so it would be a positive number. Anything less than this would give you a positive number for minus x. Anything more than 0, such as 1, if x is 1, the minus x would be negative 1. So everything to this side would be negative. Now, for this expression, minus x divided by x minus 1, minus x divided by x minus 1, write that. When minus x is 0, 0 divided by anything would be 0. So here would be 0. When x is equal to 1, what do we have? When x is equal to 1, x equal 1 would make the denominator 0. 1 minus 1 is 0. Anything divided by 0 is undefined. Remember, anything divided by 0 is undefined. So I say just U for undefined. Right? Now, the three sections, this area here, this area in the middle, this area to the right, you say positive divided by negative would be a negative number. Negative divided by negative would be a positive number. Negative divided by positive would be a negative number. Okay? Now, we wanted this rational expression, minus x divided by x minus 1, to be negative. To be negative. Where would it be negative? Well, here would be negative. That means when x is less than 0, it would be negative. And also, here it would be negative. So when x is greater than 1, would be negative. So the answer is less than or equal, actually, less than or equal. So if I was to put a bracket here, it would go like this. Greater than 1 would also make it negative. So I put another bracket here, greater or equal. So the answer is anything to the right of 1, anything to the left of 0 is the answer. Or is from minus infinity to 0, including 0, and from 1 to infinity, including 1. So that's the answer to this problem. Okay? Now, with regard to solving inequalities involving absolute value, this general rule, we say if k is a positive number, then absolute value of x less than or equal to k means that x should be less than or equal to k, greater than or equal to minus k. For example, let's do this first. For example, if I have 2x minus 3, absolute value of it, less than or equal to 1, right? Because, see if I can change the color here. Because this says less than or equal, this is the same as this, less than or equal, then that means 2x minus 3 is less than or equal to 1 or greater than or equal to minus 1. So here you would have two inequalities. Either 2x minus 3 is less than or equal to 1, or 2x minus 3 is greater than or equal to minus 1. You solve each one of these separately, so 2x, take the minus 3 to the other side, less than or equal to 3 plus 1. Therefore, 2x is less than or equal to 4. X less than or equal to 2 when you divide both sides by a 2. In this one, 2x, take the minus 3 to the other side, it would be greater than or equal to 3 minus 1. Therefore, x is greater than or equal to, 2x is greater than or equal to 2, x greater than or equal to 1. So this is the answer to this problem. That means x has to be less than or equal to 2 or greater than or equal to 1. So anywhere between 1 and 2 is the answer. Again, if you want to show this on the number line, infinity here minus infinity here, here is 0, here is 1, here is 2. Then between 2 and 1, less than or equal to 2, that would give you a bracket facing in this direction. Greater than or equal to 1 would give you a bracket facing this direction. Therefore, the answer is somewhere between these 2 points, including these 2 points themselves. Okay. So that is if x is less than or equal to k. Okay, so that's an example for that. The second rule in solving inequalities that involve absolute value, the second rule says if k is positive, then absolute value of x greater than k, that means that either x is greater than k or x is less than minus k. Okay. You can have the equal also here if you want to. It doesn't change anything. So, for example, well, let's use the same example. So you have absolute value of 2x minus 3. Now instead of less than or equal to 1, make it greater than or equal to 1. So based on this, that means that what you have in between the absolute value sign, x, but in this case is this term, 2x minus 3, would either be greater than or equal to k, k is your constant, greater than or equal to 1, or 2x minus 3 is less than or equal to, as it says here, minus k, in this case, minus 1. So 2x minus 3, well, I'll take the minus 3 to the other side. So will be 2x greater than or equal to 3 plus 2. So 2x greater than or equal to, 3 plus 1. 3 plus 1, that is 4. That means x is greater than or equal to 2. That's one answer. Then 2x, take the minus 3 to the other side, less than or equal to minus 1 plus 3. So 2x less than or equal to 2, x less than or equal to 1. Okay. So the answer is less than or equal to 1 and greater than or equal to 2. So if I want to show this again on number line, here is infinity, here is minus infinity. Let's say 1 is here and 2 is here. So one answer says x is greater than or equal to 2. So I'm going to put bracket this way, greater than or equal to 2. That means to this direction. The other one is less than or equal to 1. That means bracket facing minus infinity. And it would be in this direction. So any of those answers, anything would make this term greater than or equal to 1, right? So you can plug in anything. For example, less than 1, the easiest number is 0. 0 is somewhere here. So 0 is part of the answer. So if 2x is, if x is 0, that means 2x is equal to 0. That means this is now absolute value of 3. Absolute value of 3 is what? Absolute value of minus 3 is 3. So 3 is greater than 1. So that makes the 0 part of the answer. All right? Now we are ready to move to chapter 2.